Welcome everyone to our next info session. Just give me one moment while I share my screen with everyone. All right, well, welcome everyone. My name is Sierra King and I am the Admissions and Program Services Manager at the Data Incubator. And we are a fellowship, scholarship, and placement company. We've promised you an excellent info session today that will be led by one of our instructors, Michael Cullan. And Michael will link a notebook in the chat that he'll be using during his demonstration. So please make sure you have access and can follow along. To start things off, I would like to give you a quick overview of our program and everything that we offer, and then I'll hand off to Michael, who will jump into our live demonstration, and we'll leave some time at the end for questions. Please place all of your questions in the Q&A section, and we will answer them at the end of the presentation. And as a reminder, our session is an hour long today, so if we don't get to all of your questions, please email us at admissions@thedataincubator.com, and we will be happy to help you. So to kick things off, the Data Incubator focuses on training people to become data scientists and data analysts. So why is that important? Well, it's really because data scientists have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a ton of different industries, ranging from tech to finance, retail, healthcare, and many more. Every company has data and wants to use that data to drive value for them. So we know there are a lot of data-focused programs out there, so I'm sure you're wondering what we do at the Data Incubator that is a bit different. Well, what we found is when you look at training, there are really two types, one being fast-paced and efficient, and the other being slower and focusing on understanding and completion rates. University is one example where you'll receive a more detailed understanding, but with a lot more time invested. And then on-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. So what we've done at the Data Incubator is we've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced. You'll walk out of the program knowing a lot about data science and data analytics and the real-world business applications, and with a deeper understanding as you would get from university. All of our instructors are PhD and master's holders and have completed these programs themselves and know how to provide that in-depth training that you are looking for. My slide is going ahead of me. So we are really excited to announce for our fall 2021 cohorts, we'll be offering 3 data-focused programs. We'll continue to offer our successful full-time data science program and our more flexible version of that, our part-time data science program, and now our brand new data analyst program that will actually be running for the first time in our summer cohort. So our fall session will be our second cycle, and we will go into a little bit more detail about all of these programs as well. So again, we currently run 3 data-focused programs, and we'll discuss the similarities in all of our programs. Each of our programs are intense. They are built around hands-on data-focused curriculums, and we offer both full-time and part-time programs, and both are packed with a lot of information and tools. Each program is thorough, so we'll have a week that focuses on a different data science tool or approach. And in addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment. And so in each program, students will work on mini projects that focus on that tool you're studying. Our programs are very collaborative. We want students not only to work with their colleagues and instructors, but also have the opportunity to network and connect with our hiring partners. And part of our data science program is working on a capstone project that you have the opportunity to present to our hiring partner network. You'll get feedback on how to present, how to create a capstone with a clear business objective, and a great portfolio piece to add when interviewing with companies. And lastly, all of our programs are career focused. We have career coaches that help you succeed in your data focused careers. You'll not only learn how to present your best self by attending our career search workshops, but you'll also have the opportunity to work with one of the #1 resume writing companies to get you a polished resume and cover letter. And to help our students connect with their hiring partners, we host virtual networking events We'll have partner panels where companies will come in and talk to you about what it's like to work at a company and discuss problems they are currently trying to solve. And we, again, also host capstone showcases for our data science program, where students have the opportunity to present their capstone project ideas directly to hiring partners. And with that, all of our programs are interactive. Every student in our program is provided a Jupyter server for the duration of the course, so students can follow along in lecture and see and edit raw code as it's being run. And you'll also receive immediate feedback via our interactive grader. So our full-time data science program runs for 8 weeks, and students are expected to attend daily lectures and be available for networking events and group meetings from 9 a.m. to 5 p.m. And here is an overview of our full-time curriculum broken down week by week. Please email us, again, admissions@thedataincubator.com for a more detailed curriculum overview. Similar to our full-time program, here is our part-time program. Our part-time program lasts for 20 weeks with classes held twice a week in the evenings from 7 p.m. to 9:30 p.m. Eastern. And you'll expect to spend 10 hours per week outside of class working on assignments, and office hours will be available each week. You will receive the same excellent curriculum and training as our full-time program, but at a slower pace. And the sessions are live and instructor-led, so you're still able to interact with your instructor and cohort and ask questions. And then again, we are so excited to announce our part-time data analytics program. The program also lasts for 20 weeks, which will be meeting twice a week in the evening, 7 p.m. to 9:30 p.m. And again, you can expect to spend 10 hours per week outside of class working on assignments, and we will have office hours available each week as well. And this, again, is just an overview of our part-time data analytics curriculum broken down by week. If you would like a more detailed overview, please email us admissions@thedataincubator.com. So we admit 2 types of students into our full-time data science program. We admit fellows are offered full tuition scholarships for our full-time program. We offer a limited number of these scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our programs and are expected to interview exclusively with our hiring partners. Scholars will pay tuition to participate in our program. They are not required to interview solely with our hiring partner network and may maintain their current employment. And scholars still have access to the same curriculum and resources and tools as our fellow students. And again, these full tuition scholarships are not offered as part of our part-time program. For our data analytics program, we are also excited to announce our Data Analyst Diversity Scholarship Program, which aims to help remove barriers and provide opportunities for women, veterans, LGBTQ+, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. If you're interested in applying for the Data Analytics program or for the Data Analytics Scholarship, please email us, again, admissions@thedataincubator.com. So that is just a quick overview about our program. I will now pass off to Michael to lead you through our live data science demo, and then I will come back on the end for some more information and to help answer your questions.
Okay, thanks so much, Sarah.
Stop my screen, so there you go.
Great. I have a few links to send out in the chat really quickly. The first of these is a GitHub repository with the material we'll be working with today, and the second is a link to open up a Binder notebook server that has these notebooks kind of interactively ready to go. So if you click that first link, oh, and this is probably the right time to put these things on the screen. So if you were to click that first link, you'd end up right here, which again is the GitHub repository where today's notebook and like relevant like environment files are going to be. If you want to, keep this code for yourself or be able to go back through it later, this link will be very helpful for that. The second link basically takes you through mybinder.org, which is a great resource that lets you turn a GitHub repository, or I guess really any Git repository, into an interactive Jupyter Notebook server. And so the way that this has been set up, where I have some notebooks, I have an environment file that says kind of what libraries I need. If I set that up correctly, I pass it into Binder, it'll just spin up a little temporary server that you can use. So if you click that link, you'll actually kind of click through this part and it'll start launching your server. Eventually, you will end up somewhere that looks like this. So for those of you who maybe are not super familiar with Jupyter Notebook, you are kind of looking at the Jupyter Notebook like file tree kind of browser right now. And you're going to want to click into this first steps demo thing right here. And that finally takes us to this point. Again, if you're not super familiar with Jupyter Notebooks, it's what we are working in right now. They are a pretty nearly like ubiquitous tool in data science. They're great for working in Python as well as other languages like Julia and R. There are also ways of using Jupyter Notebooks even to write things like bash scripts. But of course, we are working in Python here. So just a little bit more anatomy of the notebook, just in case anyone has not run code in one of these before. So you'll see that the notebook is broken down into a bunch of little blocks. These are called cells. Some of these are code. We see kind of this monospaced font. We see that they have this square that says in next to it. Some of them are, markdown text, stuff that looks more like, human readable text with some formatting and so forth. So you'll notice, for instance, if you were to double click on one of these, that it would open up this editor. If you need to turn that back into its kind of original form, you might press this run button. You might hold shift and press enter. I will be holding shift and pressing enter as we go through as a way of running these cells. So at the top here, if I hold shift and press enter, you see a little asterisk while that cell runs. And I'm going to recommend, actually, we're going to be going through this step by step, but some of these cells in this notebook do take a while to run. So I'm going to recommend actually pressing this button under kernel that says restart and run all. That will do what it sounds like. I've already run through this notebook, so the really time-consuming steps will actually be pretty fast on my end, but things like downloading this data file are pretty slow if you haven't already loaded it. So kernel, restart and run all. That way you'll be able to follow along more actively. OK, all that being said, what are we looking at today? Well, I wanted to do something that was a little bit of a combination of demoing, some of the basics of the tools that we'll be using, but also demoing kind of, what it is to think like a data scientist. The ways in which we are presented with problems, from our collaborators or clients, the degree of specificity in the, kind of problems and goals that we are given, and what our role is like in, deciphering that problem or coming up with like appropriate ways to, apply database or, quantitative methods towards that problem. And so we're putting on our data science hats or data scientist hats, and we're thinking, maybe I'm a new data science hire at, let's say a new courier service operating in, let's say just Manhattan for now. So not something like UPS, FedEx, or the mail, but, kind of a more bespoke courier service maybe that does just like within the city, kind of like more urgent short-term kind of deliveries. And they're looking to, they need to make deliveries efficiently, of course, to be successful. And so we are tasked, broadly speaking, with, building data-driven tools to help out with planning deliveries, help out with organizing operations in general. And the problem setting I want to, sort of work in, and this is almost like extremely vague and maybe more vague than, we might literally see with like a real world problem we're working on, but we maybe ask something, closer to how can we better plan deliveries as compared to, something like how can we use this data set to, perform classification so that we can make this prediction and put it in this app to do this particular thing for this particular person. The role of a data scientist is not just in carrying out, highly specific and well-defined problems, using things like machine learning, but it is to sort of, crystallize that very specific problem, from within something that is going to be very vague, that is very broad. This is, kind of a collaborative process. We're not going to be just given something like this and we have to just, guess and go with it. But we'll be sort of looking at, how do I start picking apart what it means to better plan deliveries? How do I start relating that to data sets? How do I start exploring that data sets or exploring those data sets to look for some initial signal, to look for maybe data quality issues, and to then start looking ahead at kind of what our next steps and opportunities would be. So we have been asked how to better plan deliveries. And it may seem like we're being asked to build a product that already exists, a GPS kind of app, right, that tells you how to get from point A to point B. But I would contend that that's not really what we're doing, right? This isn't the same thing as opening up Google Maps and saying, this is my next delivery, how should I get there? Because, our app needs to do things like plan a lot of deliveries at once and not just for one vehicle or courier, but, to assign them to, maybe assign people with routes or regions so that they can, better serve like a group of customers. And, maybe we might say we have a fixed number of packages to deliver in one day. If we think of this in a more, so I guess something maybe closer to a mail van kind of setting where someone is loading up on items in the morning and they have to deliver them throughout some shift. We could also imagine a version of this that is, more like a, instant kind of on-demand courier, something that is closer to, let's say, calling an Uber and asking them to take something to someone. But we're going with the first approach, kind of a local logistics company, right? And we're looking to then set up maybe routes or regions that different, let's call them vans, can operate in. And that's very different, once again, from using Google Maps to say what the fastest way from here to there is. So we have to think about then, our goal is to help, provide insight on, recommending good routes for people. Maybe they have a list of deliveries for the day. Well, for one thing, how do they get that list? How do I get, delivery A instead of my colleague? And, a way of kind of sorting through those deliveries in which order we should give them, right? There's, of course, the end product of, probably something more like turn-by-turn directions, but we are entering this problem much earlier than that. We're entering this problem in, really more like the exploring and analyzing like different, possible routes or different possible things we might run into in different areas of the city. So what makes a good route? Well, we want closely packed deliveries. It would be, kind of silly if I'm driving my van and I'm delivering something, let's say in Soho and then Washington Heights and then back to Soho. And then let's say, I'm in Midtown and then I'm in the Lower East Side. Then I'm back in Soho, maybe not too bad. And then I'm going, way uptown again. But clearly that's ridiculous, right? We want to be closely packed. We want to be able to proceed, in a pretty linear fashion. Obviously, we want our route to be fast. Don't want to waste time, but there are a lot of things that go into that. But I want to focus on kind of this last point here, which is that we want a route to be reliable. As a courier service, basically a small logistics company, we are kind of in the business of being reliable. People want to know. They effectively need to know that if they're told that their product will be, or their package will be delivered by 5 o'clock, it needs to be delivered by 5 o'clock, to kind of maintain faith in the company. So we'll be thinking about this like reliability aspect. How can we think about routes, planning regions or figuring out, how many items we can give someone kind of in their quota, based on the reliability, or maybe let's characterize this as like the, variability in traffic patterns in different parts of the city. We won't be getting towards actually, mapping out regions or planning specific routes, but we're going to do some exploratory analysis on this last thing here, on the reliability, because that's something where data is really going to enter, right? I may have some, anecdotal kind of evidence that, oh, like I always am dealing with like awful traffic because people are always crashing on this street or the other, or because there's always construction here or somewhere else. But, despite my general intuition, we don't want to just take my opinion for it. We want to bring in some data. And so today we're working towards a proof of concept for how we might be able to, characterize or predict the reliability, and ultimately towards like the size of an area, or maybe also the number of packages that a particular van can service in one day. We won't get into machine learning today. We won't do any, sophisticated applications, but we'll do some kind of basic data exploration, look at some possible data sets, do some descriptive analysis, and see some of the cool things we can do hands-on using pandas, which we'll see in just a few minutes. Now, I did a little bit of an exploration already of possible data sets that might be really useful for us. One thing that unsurprisingly we will probably want at some point is a computer readable roadmap of New York City. Something that is not just a picture, but which actually encodes streets and a whole bunch of variables for each length of street that we could ultimately work into a more sophisticated application. We're not going to be dealing with this today, but our due diligence just kind of pointing out that this is going to be an important resource at some point. If we're thinking about the reliability of different streets, obviously looking at historical traffic, very important. Also, I will note that we can access real-time traffic information as well. So if we were getting to build the actual live piece of software, we would certainly want to use something like this. Taking a look at these two sources really quickly. So this is somewhere where we have traffic volume counts for 6 years. And they look something like this. These are along a street from basically one block to another, and giving the count of vehicles in hourly blocks, which, it's not immediately clear that volume is going to be super indicative of, the speed we're looking for. And I also want to note that when we're dealing with historical versus real-time information that are supposed to cover the same thing, we want them to be in the same format. And what we're going to see in the real-time API is that it is really very dissimilar. And actually, expecting to see typically something pulls up here, but I guess maybe there's some issues with the New York open data thing. But this source actually has a bunch of traffic speed detectors that measure how long it takes to get, let's say, from one block to another along a certain street. So both could be useful in various ways, but neither is necessarily like the ideal setting for us. So let's start then with this data set on collisions in New York City. I think reasonably we can say that a big reason, a big factor in unreliable travel times would be like disruptions due to things like construction and accidents. Now, if we're clever with data sources, we can actually just tap into, construction schedules. We don't necessarily need to predict that sort of thing. We can figure out where there is construction just by, ultimately finding the right place to look it up. But there's a lot more uncertainty in collisions. And so we'll be working initially with this motor vehicle collisions and crashes in New York City data set. In reality, if I was trying to solve this problem for this company, I probably wouldn't start with this data set, but it is, it's related to a big factor of the problem, and it also gives us a good chance to, dive into some cool stuff we can do like in Python and pandas without being too big or complicated of a data set like I typically find the taxi trip data set to be for working on Binder. So we'll be using these collisions. And right off the bat, I'm going to say I want this data frame. I'm reading in this collisions file. This will just take a minute as I do this. And I'm going to run a few cells while we can talk about what's going on here. So here we say pd.readcsv. This pd, if you're not familiar, refers to pandas, which is kind of the I guess, the principal like data, kind of tabular data analysis package in Python. You're dealing with tables, you're doing numerical analysis, whether it's numbers or strings or many different kinds of objects, including dates and times. You are almost definitely working in pandas. It provides a really user-friendly kind of code kind of like interface or API for interacting with data sets. It displays very nicely in Jupyter Notebooks. And it also runs very, very quickly, thanks to like a very optimized kind of engine under the hood. So we work with pandas constantly in the fellowship. Data scientists working in Python work with pandas constantly as well. When you're dealing with files that are on one machine, small enough to work in memory, dealing with pandas. So, all right. So some of the things we see in this data set, we have a date and time. We have a borough. We've already restricted to Manhattan to keep things simple for now. We have a little bit more specific location, latitude, longitude. For some reason, we have an ordered pair, a tuple that has both of those. And we have some information about what street we're on, what street we're nearby. A couple more columns that have been kind of condensed here. And then we see we have some information about vehicles that were involved. More on this later. But the first thing we want to do, given this date and time, it would probably make sense to get a little bit more specific, right? And so why don't we combine those? I'm going to say, give me the date plus a space plus the time. Now that's all well and good. I now have something that looks like this, but what I would really like to do is be able to work with this like it's an actual, date or time. I'd like to be able to ask for the day of the week, the month, the hour, and not just, a string of characters. And that's what we're doing right here, where we say pandas to date time of that timestamp column. I'll point out that this takes a little while. That's because we have about 286,000 different crashes, even after we restricted to Manhattan. And I will also say that we could speed this up if we were a little bit more clear about specifying a format that looks like this. But I actually kind of like to show that it is slow if we're not super careful about it. So that'll just take a moment to run. And I also want to note that I've now taken that code, and this may seem like kind of unnecessary or like I'm overdoing it, but I have wrapped it all up in a function, just calling it make timestamp column. I pass in my data frame, and it gives me a timestamp column. Now, why am I doing this? Ultimately, it's because I'm going to be putting chunks of code from our workflow today into functions so that if I wanted to, let's say, reuse them later or automate this process to use it in the future, it's going to be a lot more reliable, a lot more reproducible, and certainly much easier to like import code from one place to another if we actually put things in functions, right? Because now I can just say make timestamp column. Okay, now we'll come back and see kind of what some of the nice things we can do with this, but also just we probably want to get a feel for what is contained in our data set and maybe which columns will be reliable to work with. While not a perfect indicator of this, it's good to know if we have missing values. And so I'm going to say, all right, my data frame, I want to check if there are these na values, basically nan or nat, not a number, not a time, or otherwise just missing. Sometimes it's just none. And so when I do this, and I'm saying the head, which gives me the first 5 rows, that tells me for every single element, whether or not it is missing. So true here means there's no value. Okay, well, realistically, I'd like to aggregate over that. So I'm going to say, take this table and give me the average, and that's going to average over all of those columns. And so this is saying that the crash date and the crash time, those are never missing. The borough, that is never missing, at least according to this function, which doesn't necessarily mean all the values are valid. And why don't we do this one more time, and let's sort in descending order, all of our missing values. We see, for instance, and maybe this isn't that surprising, that information about vehicles 3 through 5 are rarely present. What does that tell us? Probably that very few of the crashes in here have 5 vehicles encoded. So we don't have a lot of off-street names or cross-street names. And realistically, maybe not the most reliable with the on-street names either. So we might need to think about, is it going to be a problem that something like this, which encodes the streets that I'm on, are missing like 16% of the time? Or is there a good reason for that, perhaps? Or is it just randomly missing sometimes? That's something that we would probably need to dive into more, given more time. But we note, for instance, that all of these things are never missing. And that tells us the way that this is recorded, we could imagine someone is probably filling out some kind of web form. And let's say all of these fields are, required. They're marked with a little asterisk, right? Okay, so that's a little bit of an overview of our data set. Why don't we start making it more useful for our purposes? And for one thing, thinking about our courier company and just saying for the sake of argument, maybe we're delivering between pretty standard business hours. Let's say, just for the sake of argument, we want to deliver between 8 a.m. and 8 p.m. So we're restricting to that time period. Well, I'll write a little function here that says, I want to say right now that I'm starting at 8 and stopping at 8, but I can also change that if I'd like to. And so now if I say my data frame, I'm actually going to filter on my delivery hours. So I'm going to get rid of everything outside of that window. And I'll also note that we've created an hour column now. And I can look at that hour column and I can get a little histogram. And that's going to tell me, it looks like I have, I guess we might call this kind of a trimodal looking distribution according to our little histogram here, where we have a lot of crashes between 8 and 9, a lot of crashes, it appears, between 2 and 3, and then a lot of them between 7 and 8 as well. And so that's one of the things that, we can start doing when we have that date time kind of column. Very useful. In the fellowship, we explore much further a lot of the cool possibilities of working with dates in pandas, but I want to keep going and kind of show a few other meaningful things. And I want to talk a little bit about locations and different ways we can think about locations. We're given this location column, we're given latitude and longitude, but that doesn't necessarily tell us, how we travel through the city. We can't just go from point A to point B directly, right? We can't travel as the bird flies. We have to, navigate the grid of streets. It's a whole different kind of distance. Not for nothing, like a math setting, there actually is a Manhattan distance that refers to those kinds of straight lines. But what I want to do is I want to say, all right, well, why don't I think about the intersections of the city? I have this on-street name, I have this cross-street name. And so I can, think about if I'm at the juncture of 2 streets as like a more, domain-specific type of location. And so I'm going to say just put those 2, strings next to each other. And I'm going to look at now this DF intersection. And I've created something here that says, all right, this was on Prince Street and the cross street was Wooster. This one was on Broadway, cross street was West 161. And, we can, from there, why don't I say, all right, well, what are my top 20 intersections I'm running into? And so we take a look at this. Perhaps unsurprisingly, it looks like we're seeing some kind of stuff in Midtown. On 125th Street, kind of at the, I guess, kind of the bottom border of Harlem, certainly a very busy street. And, I guess to the extent that we are familiar with the, kind of map and traffic patterns in New York, a lot of these are probably not that surprising. But, maybe we want to go a little bit past what we're just seeing in these strings, because, notably we have things like 2nd Avenue, 2nd Avenue, 2nd Avenue. We see the same streets repeated, 42nd, 42nd. And it might be nice to be able to deal with those, as numbers, extract the street and or the avenue, right? And we'll do that just for the street here. Realistically, we could do it pretty easily for the avenue too. But I'm writing a function that says get street numbers. And when I run this, I'm getting a little bit of a warning here, which is not super critical to go over. But what I will mention, we look at df intersection, is that now where relevant, we have a street number. So 36th Street, 66th Street. And we've decided that we want to include these, whether it's the on or off street. That is something we could have made an argument for or against. And I'll note that this is something I did by using a regular expression, something that we talk about a fair amount in the fellowship, which lets me extract a match or extract a kind of type of string that looks like a particular pattern. I'm saying I want some numbers followed by ST, because that's how I'm seeing street. I can do some other interesting things here. For instance, I could restrict to things between 1st and 14th Street. So, kind of a, I guess, not quite downtown area, but things that are, roughly bound between 14th and 1st, I guess, obviously, and make kind of an indicator variable. Now, from there, I could say, if I'm working, roughly within this area, where are my accidents happening? Well, off the bat, we see that basically all of them are pretty much on 14th Street. Which makes sense because that's kind of the main drag in that region. So maybe I say, okay, well, what about between 1st and 13th? Because this isn't necessarily that interesting. And so we can kind of make an indicator variable and check that as well. I have to move a little bit fast here, so I want to go over a few other things we could do. Obviously, not all of Manhattan is built on like that standard grid. Of course, we have just kind of string names. We're not dealing with those currently, but I want to give kind of another reliable pattern, which is just a couple of blocks in the East Village, often referred to as Alphabet City, where we have Avenue A through Avenue D. And just showing how we have like a slightly different way of, we can use kind of a similar regular expression to do something slightly different. And so what I'm going to do now is I'm going to say, all right, give me all of the avenue letters. If I find avenue, something like this, in those, in that intersection name, I could restrict my data frame to just those things that I found, along one of these avenues in one way or another. And now in that particular small neighborhood, maybe that's something where I could say, all right, well, what are my main places where I'm seeing accidents? And again, unsurprisingly, to the extent that we might be familiar with this area, actually pretty much all of those are happening on East Houston because this neighborhood itself is actually very, very quiet. But it's kind of just to show again, ways that we can get meaningful and interpretable information out of strings, using these kinds of tools, and we can do so in pretty flexible ways. I also might be interested in, let's say the number of vehicles in an accident. Oddly enough, it's not directly encoded in the data set as we have it. Rather, we're given these vehicle type codes, these 5 columns. Let's say, all right, vehicle 1 was station wagon or SUV. Vehicle 2 was a sedan. Vehicles 3 through 5, not there. In this one, a sedan crashed into apparently nobody else. In this one, it looks like there were no vehicles involved. Hard to say what that is. Might merit further analysis, but we'll ignore that for now. But oddly enough, the data has been set up in a way where we can't just directly say there were 2 vehicles here. We need to compute that. And so we'll use our, checking for missing values. And I'm actually going to write a function here that computes this. And then it just adds up how many trues we have as the number of vehicles. And so when I do this, if I look at these num vehicles here, that has gotten, 2, 2, 2, 1, and 0. And that's for all the other data set as well. And from there, I can make a little histogram. Unsurprisingly, we have really mostly crashes with 2 vehicles, probably stands to reason. Although we might be interested, maybe in places where we're more likely to see these crashes with more vehicles. So we might assume that, with more vehicles involved, it might be a greater disruption to traffic. That is a reasonable assumption we're making, but maybe not always the case. So I'm going to say, all right, I want to take this. I want to join it back onto my data frame. That's kind of a different way of making a new column. It's not the way we did it earlier. And I'll note that we might do this if we had two totally different tables we wanted to join together. Or maybe, where they don't just go squish next to each other, but maybe we have kind of a lookup, looking up like a key value situation. Kind of a more SQL style way of combining data. And here we see that we've brought this in. And, just kind of continuing our brief initial analysis, I might also ask like, okay, well, if I look at all my different intersections, do I find any kind of meaningful information if I were to look at, let's say, the count and the mean of those? Well, broadly speaking, everything looks like it's basically around 2. It's not clear that some minute differences like this might actually do anything for us. If I was interested in sorting these by the mean, well, this might be an issue for us because maybe we would find intersections that have only been encoded or only been mentioned once. Luckily, we also find in doing this, because we've ended up with rare values, we find that maybe we have a data encoding issue we didn't see before. Made the assumption at the beginning that everything was in all caps because everything we saw was in all caps. And then we see that every once in a while something gets entered incorrectly. We're in this iterative process, kind of a messy process, and we might need to now go all the way back and try to deal with that. Maybe just make everything lowercase. But that's not for today because I've already gone for quite a while. This is like the beginning of the beginning of the beginning of an analysis for solving a problem like this. But I did want to, be able to discuss what we need to do, when we're given vague business problems, how we start looking at data, how we relate that data to, actual goals or, attributes of solving a problem, and then how we start assessing, kind of what is in that data and where we might find signal initially. But where would we go from here? Well, aside from expanding the analysis itself, we might want to make sure that we could send this to, our colleagues or our clients. And so to that end, it's good to make sure that they can run the code as well. So we might want to take this notebook and package it up kind of in a virtual environment, something where someone can automatically install all the necessary software with all the same versions that you have. Their, environment for running it is now identical to yours. We also might want to host it online so that we don't just have to, send somebody a zip file. So hosting notebooks on GitHub works pretty well. That's what we did here. Binder is great if you're okay with a, public notebook, or, when you're dealing with private ones, a lot of companies actually have their own Binder servers, if not just full Jupyter Hub servers. Although, when doing this, we need to be clever about how we download our data. You'll see at the top of this notebook one way that I did that. So really helpful to work on things to make results easier to share. And then, of course, getting back to the problem, right? I might want to do things like assuming I actually had delivery information, which we don't now. It's kind of a hypothetical business case we're working on. How can I handle grouping those by location? Should I kind of use like reasonable rules of thumb, like, oh, here's someone who delivers to the East Village, or maybe more appropriately, do I want to compute those regions or those groups of deliveries that go in one van in a more data-driven way? Might use some unsupervised learning with something like clustering to find those kinds of patterns that we can exploit. And we'll start working towards a predictive model, right? Predicting the best route or the best allocation of boxes to different vans and so forth. And as we keep iterating, continuing to bring in more data, continuing to refine our analyses and kind of refine the problems we're solving. Okay, it occurs to me now that I've been speaking for a very long time. I certainly need to pass things back to Sierra for now, who has some more information about the fellowship and the analyst program, but we will have some time for questions at the end. So please do sit tight for any questions you do have.
All right, thanks, Michael. Let me get my screen pulled back up here. Hopefully you all can see that. All right, so just a little bit more about our program, going into our placement services and employment rates. A big component of our program that we really pride ourselves in is helping our students not only to grasp data science concepts, but also getting placed in that field. So our analyst program, as I mentioned earlier, is brand new. We don't have data here yet, but for our data science fellowship program, we see that 97% of the students that go through our program are currently employed outside of academia, and 82% are employed within 6 months of completing the program. Those are really great numbers. We're very proud of those and have worked really hard for them. And then that's part of the challenge, not only learning content like you did today, but also being able to transition into a data science or analyst role. And that's really where our program stands out, because we help you to do both. So quick update on our graduates. Where are they working? What are they doing? Again, data is not available just yet for our analyst program, but for our data science fellowship, this will give you an idea. Our graduates are working in 55 different industries, and some of the most common industries we see are computer software, internet, IT, financial services, and biotech. And then some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. And these titles and roles will vary depending on the company and industry, but these are just some of the ones that we've placed in the past. And then here is a short list of some of our hiring partners for our data science fellowship program. Many of these companies are also hiring for data analyst roles as well, but we are also focused on building a separate network of hiring partners dedicated solely to our data analyst program. A couple students have asked about financial assistance, if we offer it, and yes, we do. We know that especially during times like these, it's hard because you may have extra time to participate in the program, but limited cash flow. So we want to help you with that. We've partnered with LEAF to provide an income sharing agreement. It's great. You can participate in our program with just a deposit down and won't be required to make any payments until you've graduated and are working and earning more than $40,000 annually. We also provide loans through Ascent, and Ascent offers 3 loan options: 1 deferred repayment, so no repayments during the program and 3 months after; interest-only repayments, so small interest-only payments during the program and for 3 months after, and then full payments. And then they also have the immediate repayment, so begin making full payments 1 month after the program begins, and for 36 or 16-month terms are available. Lastly, for many of our part-time programs, our companies are willing to sponsor or pay for their employees to go through our program. It's a win-win. You get to learn great stuff in the evening that you can apply to your job during the day. So if that's something that you think you're interested in or your company would be interested in, please email us, and we have a letter that we can provide you that you can send to them just to show the benefits of attending. So some important dates to keep in mind are full-time summer cohort, our full-time fall cohort will begin September 20th and run through November 12th, and our part-time fall cohort will begin September 20th and end February 4th, 2022. We do run multiple cohorts a year. As I mentioned, we just wrapped admissions on our summer cohort, and our fall cohort application will open on June 1st. As I mentioned earlier, the full-time cohort is 8 weeks long and the part-time cohort is 20 weeks long. And some specifics about the data science application. We ask that you submit your application by July 9th for our early admissions, and then you will have 72 hours to complete the coding challenge from the time that you open it. And the coding challenge deadline, again, for early admissions is July 12th. You cannot complete the challenge unless you submit the application. So just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We are unable to reopen the application or challenge after that deadline. And that's for our early admissions. We also do regular admissions after our early admission cycle. And really the difference there is we evaluate applicants on a first come, first served basis. So if you want to have a better chance of getting one of the fellow spots in our full-time program, or just knowing earlier if you've been accepted into our program to secure financing, I absolutely recommend applying for early admissions. In addition to that, we also offer a priority enrollment package for our data science program that includes access to a Python training course, early access to career services, and a one-on-one with a data science resume writer, as well as $2,000 off your tuition for direct payment. And then for our data analytics application, our application is broken into 2 parts before we make the decision. One being the application plus the optional diversity scholarship if you choose to apply, and then the interview. The application deadline for the data science program is July 30th. If you're interested in applying to our programs, which I hope that you are, you can go to the dataincubator.com/apply to submit your information, and you'll be notified once that application opens. And if you have any questions about your specific situation, the presentation, or going through the application process, please feel free to reach out to us at admissions@thedataincubator.com, and we'd be happy to help answer your questions. So at this time, I will open up the Q&A. I know there are a couple technical questions in there, Michael, if you want to just get started with those. And then if anyone else has some additional questions, please put those in the Q&A as well. So the first, sorry, go ahead, Michael.
I will take these two questions that John brought up. And the best thing to do here, I'm going to switch over to my screen if that's all right.
Sure.
Just to show a few things here really quickly. So John, your first question was about this df all variable. So what I actually said was it's not a function, it's just like it was another data frame before I filtered down to Manhattan. So to work with, just so I could work with less data to start with, I said, all right, well, let's think about just our deliveries in Manhattan. So I had to load everything. Then I filtered down to Manhattan, and then I deleted the big one from memory. So we just had the small data frame left. And then your second question, you said that you think you can use often simple imputer to fill missing values. How do you fill the mean of some row and not all rows? And then kind of some more, I would say, maybe like domain specific questions, but how do you fix missing objects in some row? Should they stay nans? Should they stay as whatever they currently are? So firstly, I'll say that if you want to modify some rows in a column instead of all of them, that's something you can always just do by filtering, kind of the same thing that we're doing here, where I'm saying, all right, filter down for just the rows where borough is Manhattan. You could do the same thing, and you could say, all right, for all of the rows where, some value is equal to something else, or whatever filtering condition you want, just in those rows, modify, whatever column you're trying to fill in. That's maybe a little bit vague, but broadly speaking, what you do when you want to modify part of a column is you do filtering. And then the other question you asked, I would say, is a real it depends kind of question. Some values are appropriate for imputing, filling in with like the mean and things like that. Some values, it really wouldn't make sense. It's not immediately clear to us if it would really be reasonable, for instance, to fill in something like latitude and longitude, especially if it was just the mean of each one separately. Maybe we could. And we probably still wouldn't want to say that every single crash that we had that was missing a latitude and longitude was happening at the exact center of all of our data points. So that one is something we would probably just want to discard those rows or see if they're going to be an issue or something that we can discard. And I would say that kind of is the case for a lot of these. And I guess we don't have a lot of numerical missing values here. I guess those are some of the main ones. But likewise, like we're not going to fill in like the cross street name with, let's say, like the mode, the most common one. It really depends on what you're doing with it. If you're trying to compute an average with missing values, it can be appropriate to fill in the mean. If you're trying to compute a sum with missing values and you fill in the average, like that might be not the most appropriate thing to do. So missing values, it's a really like deep topic. It's hard to answer those kinds of questions in general, but hopefully those are some helpful directions.
Another question in here, and Michael, if you can help me answer this. Is this how a live class or session will take place once the students are in the program?
I would say yes and no, more no than yes, however. Yes, in the sense that we work out of Jupyter notebooks and we kind of go through them while lecturing and everyone is able to follow along on their own server. Although they have slightly more permanent Jupyter Hub servers instead of these like binder ones. And also I'd say it's not really the way class goes, because we move really quickly in this demo to just, it's a demo. It's just to show some things off. The classes are more in depth. They're certainly more interactive. There's a lot of discussion. There's a lot of exercises, a lot of questions. We keep things more open-ended. And the pace is a lot slower and more in depth, but still, almost always built on top of like hands-on stuff with real-world data sets.
Well, I just want to take the time to thank everyone for attending today. Unfortunately, we've run out of time for questions. So if you have any additional questions for either Michael or me, please feel free to email us at admissions@thedataincubator.com, and we will be happy to answer them for you. Keep note of these dates. Again, our fall application will be opening very soon, so I encourage you to go to our website, sign up for more information so you'll be notified first when it is open and you can apply as soon as possible. Again, thank you everyone so much for attending today, and I hope you have a great rest of your day. Bye, everyone.